So, hello everybody, and welcome to our talk about sustainable secrets management. First, let's present ourselves again.
I'm Pascal Reeb. I'm a cloud-native architect at Adfinis, working with secrets management since nearly 6 years at Adfinis, and I'm based in Basel.
And my name is Toni Tauro, and also a cloud-native architect. I've been working for Adfinis for the last 7 years, and recently also been doing secrets management stuff for the last 3 to 4 years. Something about Adfinis: we run an open source service provider. We have lots of customers. We help them with a variety of things. As you can see in the bottom, we have different teams that also do classic IT or cloud native stuff. And when we say cloud native, doesn't mean that everything needs to run on the cloud. We do stuff that is cloud native, which can also run on premise. We have also 24/7 support and are based internationally, as you can see, and we are over 150 engineers. We are also, though, leading secrets management experts. We have been doing a lot of successful projects. We still are running managed service for our customers. We have a lot of experienced specialists, but what is important for us is the open source factor. We are upstream maintainer for some softwares, steering committee members as well, and are supporters of the community. What is secrets management? The base of this talk we are doing today. We need to take a look at what secrets are. And most of you might know already what secrets are, but what we see at customers, it's that secrets are imposing a huge risk in the company. They are being shared around. You go over to the DBA and ask for the DB password. Really, that password has been there for 5, 6 years. The credentials can be hard-coded into the code even. We saw secret sprawl is happening. A variety of services are using the same secret, and once you change that or want to rotate that, you have a problem because you don't know which services are accessing it, or are using it, and you don't have any audit trail, no logs, no traceability. You don't know which services are accessing it, reading it, or writing it. Lack of policies, and your application don't integrate well with that, as you don't have an API, you can't reach your secrets in a safe manner. So what is secrets management then? It's a way that we want to make sure that the secrets are stored safely, centrally, and we focus more on the machine side. And when we go to customers, usually what we hear, oh, no, the password manager. No, it's not a password manager, please. It's not meant to keep your Facebook login in there. It's meant to keep your secrets in there that are used by the machines. So we are machine-centric. So these solutions need to be super secure, highly available, flexible, and integratable with your application, and your developers must be able to integrate with it very easily. But this secrets management ecosystem has a lot of challenges. So the solutions that are out there try to sell you licenses. We end up with an architecture by license at customer that they say, well, if we are going to pay by client or by identity, let's put a proxy in between and make it even less secure, basically. To reduce the cost, they end up with this architecture by license, as we can call it. So we asked ourselves, isn't there like a sustainable option that is free, open, simple, and reliable as well? And this is where OpenBao is the answer we found. This image is actually not AI generated. We took a photo with my Android phone. I'm joking. So what is then OpenBao? It's a modern open source secret management solution that solves the problem of a lot of secrets you want to store in there, like static, dynamic secrets, DB passwords, DB generated passwords, certificates. There is a PKI engine, key management, and more and more. It has strict access control, encryption at rest, of course. You have an audit log there, so you see who is reading, who is writing or rotating your secret. And the most important part, some of you may already know, it's a fork of HashiCorp Vault. And it's now owned by the Open Source Security Foundation, which is, in fact, part of the Linux Foundation. So it's going to stay open source like that. Why should we then choose OpenBao? Of course, the sustainability. The license isn't going to change. We are still being, we are going to be able to stay under the Linux Foundation umbrella, and there will be no restriction at all by any licensing model. You will have full sovereignty, and not only in the cloud. This stuff runs also on-premise. So no artificial restriction there, full control of your data. And the innovation, of course, any feature that is being pushed there will be available for everybody, even if another firm or another company might share that into an investment or promote it as a feature. Why should engineers choose this? Well, it's easy. API is still compatible with HashiCorp Vault, so it's API driven, it's easy to integrate. There are various integration options out there. Every single use case you might search into a secrets management solution will be covered by it. The feature set is really broad. Many out-of-the-box integration are already there. The roadmap is fast-paced. We want to push a lot of features in the next time. And the architecture is resilient. We have high availability there, failure tolerance. Disaster recovery is coming at some point. We still are not there yet, but we will. And you can deploy it on-premise, as I already said, for 3 times, I guess, by now. And you can manage the whole configuration with infrastructure as code. OpenTofu as an example. I won't name Terraform explicitly. I'll give over to you, Pascal.
Thank you. Yes, we as Adfinis, we are all in with OpenBao. We are core members of the organization. We are part of the technical steering committee. And we also have multiple maintainers in the core and the Kubernetes part of OpenBao. We are contributing to all the working groups there are currently, and we are leading the horizontal scalability, the UI 2.0, and the supply chain security working group. We co-developed multiple new core features like namespaces or horizontal scalability. And we foster the community and the whole ecosystem by bringing, for example, our partner Securosys into the community part of the PKCS 11 working group. And we are promoting OpenBao in all aspects with our customers. OpenBao itself, to run especially in either on-premise or in the cloud, can be really challenging. It's typically deployed highly available with multiple clusters to ensure that you don't lose access to your secrets, because that could result in losing access to all your data. It usually runs on VMs or on Kubernetes, and it has 2 options for storage backend. One is Raft, which is the integrated storage, and Postgres is the other option. Postgres is usually only an option if you already have a highly available Postgres cluster and really good DB administrators. When OpenBao starts up, it's usually in a sealed state. And in this state, it cannot decrypt its own storage and its data, so it must be unsealed. The mechanism behind it is the key encryption keys, which maybe some of you know. There are 2 options of unsealing. One is manual unsealing, where you need to find a specific threshold of key holders to go together and to unseal the cluster. The other option, which is highly recommended, especially on production, is to auto-unseal the cluster using a key management solution like an HSM. There are different kinds of auto-unsealing options. One, and probably the easiest, is to use one of the hyperscaler public clouds like AWS or Azure. And then there's the option of using HSMs like the Securosys Primus HSM through PKCS 11 or KMAP. The third option is there usually just for the beginning, using static keys, which means that you have the key material together with the database on the same node, which is not really recommended. Especially an HSM is especially important if you have regulations or you don't want to go into the public cloud, if you want to minimize external dependencies and retain sovereignty. And for this, OpenBao loves Securosys. We brought in Securosys into the community, and we tested all the features that OpenBao provides together with the Securosys HSM, and have the Securosys HSM is the first officially supported and verified HSM for OpenBao. The auto unsealing currently works through PKCS 11, which is a standard protocol. Probably you all are aware of it, used by a lot of HSMs. Auto unsealing itself increases the uptime, or especially like compared to manual unsealing. If in the night your cluster crashes and you need to find 3 operational engineers or key holders, that can be really challenging. With auto unsealing, you just need the HSM. There are some restrictions with the PKCS 11 protocol. For example, as you already seen at different talks, the advanced security workflows like approving through the Securosys app is not possible through PKCS 11. I want to show you a small demo on how easy it is to run OpenBao and auto unseal it using PKCS 11. I have this simple architecture for the demo environment. We have a Kubernetes cluster on the left, which runs 3 pods where OpenBao is running in. Each of the pods has an init container, which is injecting the PKCS7 library from Securosys. And on the right side, we consume the cloud HSM from Securosys using 2 HSMs for replication. To build the init container, you need to do that yourself currently. It's pretty easy. I just created a small install script which fetches the Primus API from a local registry and then unarchives it in /user/local. Putting that into a Docker file, building it, pushing it into your container registry so it can be accessed by your Kubernetes cluster. Then you need to create your Primus configuration. You most likely already get it from Securosys. In this example, there's 2 HSMs. The second one is just ... Both are configured as slot 0, which ensures that the key is stored in both HSMs. To access the HSM from inside the pod, you need to create a secret, which contains your .secret configuration you get after initial authentication. Also your HSM pin to access your partition. And also creating a config map based on the Primus configuration I showed you earlier. One caveat of the OpenBao PKCS 11 integration compared to the HashiCorp Vault integration is that you need to create your key material inside the HSM manually. For this, you can just create a key using the PKCS 11 tool. In this example, it's an AES key with the sensitive flag, so it's not exportable as plain text, and the undestroyable flag, so it cannot be deleted, because deleting the key would also delete the access to your data. Then you need to adjust your Kubernetes deployment. In this case, we just prepare our Helm values. We change the container image to have the HSM container, which has the HSM seal enabled and also contains glibc, which is required by a lot of the PKCS 11 libraries. Then you can just specify your seal stanza, which just references the library, the key label, and the mechanism used for the key. You then, of course, need to mount your secrets, your config, and also the Primus library down there is a volume that is populated by the init container. As you can see, the Primus volume is an empty dir. The other ones are referencing the secret and the config map. And then you just add your init container, which runs on pod. After pod scheduling on the startup, it runs once, extracts it to the user local Primus, and then the library is available for your OpenBao container. Then just an easy install, and you can see the pods are running. They are not ready yet because they need to be initialized. There's a new feature called self-initialization where you can automate the next step, but in this demonstration, we just do it manually. You can do that by execing into the container, running bao operator init, and that's it. You have a running OpenBao cluster unsealed using Securosys HSM. You can even verify that using the bao status command. You can see the field type is PKCS 11. It's initialized, it's unsealed, and it has 1 recovery share and 1 recovery threshold to generate a root token. the amount of shares and the threshold you can specify during the initialization. Yes, and what's about the transaction security broker API? We already heard a lot about that today. There's currently a working prototype for OpenBao to be unsealed using the TSB, but there's no official integration yet. It would then just use the REST API, so you wouldn't need to use the special HSM image. And you can even create advanced security workflows using the app. For example, if you want to have an OpenBao node unsealed, you can have that requiring approval through one of the operational engineers. Or you can just have notifications, or also in the future, when you generate certificates or sign some data using OpenBao, you can require special authentication. The only downside we saw so far using the TSB is that it introduces a higher latency. So PKCS 11 is way faster, especially if you introduce an approval process that takes time and could impose some workflows to stall or run into an HTTP timeout when requesting a certificate, for example. So what's on the outlook and the roadmap? So we see that Securosys is actively contributing to the OpenBao community, and we are really happy about this. We see that there's first-class support for premise HSM with OpenBao. Actually, there are currently only 2 verified HSMs, and Securosys was the first. And soon there will be support, which already got first working prototype, using external keys to store even more data, even more keys inside the HSM, not only to auto-unseal it using the HSM. And then there's going to be per namespace auto-unsealing, where you can, for each namespace in OpenBao, can have a dedicated key or even a dedicated HSM to ensure segregation of customer data. Yeah, and that's it. I'm happy to answer any questions. Even after the talk, we have a booth here. So feel free and come up to us.